Anzac Day today. Of course, Anzac Day is a commemoration day for the Gallipoli landings for the Australian and New Zealand soldiers back in the First World War. It's their day today, or the relatives and that. We'll have a beer for them shortly. So today we're going to carry on with Project X. So we're going to be finishing the external freehand radius features on the bearing block. This is the one that last week we machined the internal radius for the little stainless steel bearing. So we'll carry on with that. Oh, and by the way, we do have a new addition to the shop, which is up there on the wall behind me. So we'll swing you around and take a bow peep. Well, here's the new addition to the shop. So if you're anywhere in Western Australia, this is the place to be on my sticker board. Okay, if we're looking at the drawing, the shaded yellow section is the part that we made last week, which is that. Now, we have our cast iron housing here, shaded area here. So our first step is to rough out the basic shape. See, our finished size here is 2" OD, so we rough it out to 2.5" OD because we have a 1/4 inch radius. It's a blending radius, it goes sweeping, goes up and around. So yeah, as I say, we first rough it out to 2.5" OD and then we'll tackle the radius. For the internal one there, I might actually see if I've got a form tool for that one, and this external I think we'll just do in freehand. And then we part it off, flip the part upside down in the mill and come in, and we have 2 slots to do on either side, 3/4 inch wide, and that will be the entry point for our ball, because the ball will go in sideways and then rotate around and be locked in position. So we'll carry on with that. And the item I just used then for a camera mount, or an iPad mount, is kindly donated by Mr. Bruce Witham. These are a couple of large diesel engine gudgeon pins, which make a good square reference surface to work off. Well, it worked for my iPad. As the usual camera stand, which will either be an old surveyor's tripod or mag base sitting on whatever it sits on. So one day we will advance and get a proper camera and a proper camera stand. So anyway, we'll move on. Okay, we'll get started on our first radius. Working the tool in the corner there just to keep the shatter down. Okay, that's looking good. Check our length. We're looking for a 1/2 inch, which we're pretty well smack on there. And the other way, We're looking for 2 inches. So we've got about 20 thou to go. Okay, that's looking quite good, that. Very happy with that. So we're bang on 2 inches for our diameter. Check our length. Bang on ½ inch. So we're good with that. Okay, so now we'll do the other corner radius there. We'll just check that one with the radius gauge first, see how it came up. Looking very good, that. That's spot on, 1/4 inch radius. We'll just use our more and right radius gauges. That's an old set, these used to belong to my father. So now we just have to do the very corner radius. Now I could do that with a form tool. I have a form tool here which will do the job. So we might swap over, we'll have a play with another form tool. Just for something different. Okay, well that's our radius features machined up, and we gave it a bit of a polish too. So now we'll move on, we will part this thing to length and then put her in a mill. Okay, so we've got quite a deep parting off operation here to do, so we'll go on as far as we can and then we'll extend the tool out for the last piece of the cut. So I've set our depth ½ inch. It's just a ruler measurement. We want to be running on a fairly slowish speed, so Okay, so we'll adjust our tool out. They're not just a deburrer, you can use them for getting the rubbish out the top of the cap screw heads so you can fit your Allen key in. Now, there's our ruler. So we want enough tool hanging out probably to go 1.5 inches. We'll see how that goes. If we have to adjust it again, so be it. I'd rather keep that tool as short as possible, being such a deep part. There we have it. And as usual, I'll always take the ragged edges off the scrap piece. It's okay, it's just so we don't cut ourselves next time we pick it up. So we've got a good piece left over for another project. Don't know what it could be, but it has possibilities in the future. That's why we chose to part the piece off and keep the blank rather than machine it all off. Oh, there's the pile of cast iron machinings, chips, what have you. So rather than all that go into the lathe, we've saved that. I'll give that to the wife. She'll put it in a pot plant or something. Well, okay, we've got the part mounted up in the reverse jaws on the 3-jaw chuck, so we can face the back off, and then we just have to cut a bit of an angle chamfer in there into the exit point for the hole. we'll check our width. We're after 1/2 inch. 509, so 9th thou to go. There we are, 1/2 inch, so we'll just break that corner. Okay, that should do it. Oh, okay, this is our completed part, well nearly, so we're off to the mill. We mill the two reliefs opposite each other, so our ball bearing, it's not really a ball bearing, our inner sphere can go into the race. Okay, now to cut our reliefs in the underside of our part, we are going to use the rotary table. So we'll set her up central to the axis of the spindle, and we'll use the Blake coax to do that. Okay, we've set the part up on the rotary table with a couple of strap clamps, and we've just got the Starrett last word indicator to centralise the part to the rotary table. So we're looking pretty good there. Okay, so we've got a 1/4 inch end mill set up, so we'll use that to go and do these slots. So we're just going to mill it a slot 3/4 of an inch wide, and the depth will be when we reach the maximum diameter of the sphere inside. So okay, that's our pocket milled out, so we'll clean her up and give it a test fit. Okay, well, all bar the 6 holes we have to do on the PCD around the outside, 6 countersunk holes. This part's completed. This is the outer race for the bearing. So that's our spherical bore inside, and on the rear that's our entry slot that we've machined in for the ball to go in. So what happens is we get our ball, it goes into the slot, snaps in, rotates around half a turn. So there's our spherical ball race. Right. Can't come out that way. Only one way out, and that's 90 degrees around the back. And with the thumb pressure, out she pops. Clips in, rotates around. So that's part finished, bar the holes that we have to drill and countersink for the mounting. So the next part will be playing with, we have this chunk of Kaiser 7000 aluminum. So this will be the housing that this part mounts to. So we'll move on to... Well, we've got some visitors into the shop today. Come to check up on my work. Chook, 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 chook. I don't know what they'll find in here. Maybe a couple of spiders. Alright, I just want to thank all my viewers and subscribers. Thanks a lot for staying on board. And as we said, next week we'll continue with the housing out of the Kaiser 7000 series aluminium. Anyway, catch you later.